Alright, so today we're going to start talking about prisms. We had to cut some stuff out for time's sake. We'll make up for that in class. So today we're going to start talking about surface area of prisms and cylinders. Big difference. If you're asked to find lateral area just means the area, the surface area of the prisms without the two bases. So it's basically just the sides. That's what it's pointing to here. If I've got a prism, my two bases are the sides of the prism that are parallel to each other. So in this picture, it'd be this triangle and this bottom triangle. Those two are the two parallel sides. Those are your bases. So if you're trying to find the lateral area, it's going to be just the area of these three rectangles, these two in the front and the one in the back. To get it, you take the perimeter of the base and multiply it by the height. Again, you don't have to memorize these. It's on your formula chart. If it ever just says surface area, that means the whole thing. That is the lateral area and the two bases, so it's the area of every single face on your prism. And here's some formulas to help you get it. Again, you don't have to memorize these either. These are on your formula chart. Lateral area of a right cylinder. Again, lateral area, it's only talking about the area of the side piece, not your two bases. That's why it's pointing to it here. So to get the lateral area of a cylinder, there's your formula. Basically, you take the circumference of the circle, which is 2 pi rh, and multiply it by the height. Think about why that is. I'll demonstrate in class why that is the case. Think about why the lateral area of the cylinder is just the circumference of the circle times the height of the cylinder. And again, if you wanted the total surface area, you take that lateral piece that you just found, and then you just add the area of the two circles, the area of the two bases, the top and the bottom. So again, don't worry about memorizing these formulas. Know how to use them. You'll have them on your formula chart. Now we just have a whole bunch of examples worked out for you. So that's all this page was a bunch of examples worked out for you. So there's the first one. Area of the base. Well, what is the shape of the base? Shape of the base is a rectangle. Area of a rectangle is base times length times width. 9 times 4, it's 36. Okay, the lateral area, how do we get that? We take the perimeter of the base. Take the perimeter of the base, 9, of course that side's back, also 9, plus 4, plus 4. Take the perimeter of the base and then multiply it by the height. And you've got the perimeter of the base times 3, which gives you 78 feet squared. So then to get the total surface area, again, if it just says surface area, that means the total. You take the lateral area, which was 78, plus two bases, because I have the top and the bottom. So this was just the area of one of the bases, but I have two. So I got to multiply my base area times 2, add it to my lateral area, and I get 150 feet squared. So we do it again here. So it gives me a triangular prism. What are my bases? Again, my bases are my two parallel sides. My bases are my triangles. Base area, base times height divided by 2 for area of a triangle, gives me 5 centimeters. Lateral area, again, you take the perimeter of the base, add up the perimeter of the base, multiply it by the height of the prism, gives you 86.8. And then to get the total surface area, or just surface area, I take my base times 2, because I have two triangles, so that'd be 10, add it to my lateral, and I get 96.8. How does a cylinder work? The exact same way. Base area. My bases are two circles. How do you get area of a circle? Pi r squared. Radius squared is 25, so it's just 25 pi. Lateral area, I take the circumference and I multiply it by the height. Circumference is 2 pi rh, so that would be 10 pi. And then 10 pi times 6 would be 60 pi. And now add it up, because I have two bases. 25 times 2 is 50, so 50 pi plus 60 pi gives me 110 pi inches squared. Got another cylinder laying a different way to work the exact same way. Base area, the diameter is 8. Radius would be 4. 4 squared, 16 pi. Lateral area, again, I take the circumference, which would be 8 pi, 8 times 15, 120 pi. Add up my two bases plus the lateral area, gives me 152 pi. Good thing about these problems, it's all on the formula chart. You don't have to memorize anything. You just have to know how to use it. It's really a test of your algebra skills too, because once you got it set up, sometimes they want to know a height or they want to know a width. They give you the area and they want to know what the width or the length is, and you just have to do the algebra to get the piece that you're trying to find. Okay, so now we can find the surface area, again, it's focused surface area of a composite 3 dimensions. So we've done composite figures in 2 dimensions. Now we're going to do them in 3 dimensions. If I want the surface area of a composite 3-dimensional figure, I take the surface area of one of the prisms, add the surface area of the other prism, and then subtract the hidden surfaces. So what does that mean? This is what it looks like. Alright, so I take the surface area, so this one I have a small prism and a big prism. I take the surface area of the smaller prism, and I take the total surface area, and I get 32 centimeters squared. That is the face, that's the area of each one of these faces added up by using the formula you have on your formula chart. I then took the area of the larger prism, which is 48 centimeters squared, again using that same formula. So now if these were 2 separate figures, not stacked on top of each other, and I wanted the total surface area, I would just add these up. But notice they are sharing a face. So this face, the bottom face of the top figure, is being covered up. And part of the top of the bottom figure is being covered up. So we need to subtract that face from the bottom figure and that same face of the top figure. So what is the area of that face that they share? It is 6 centimeters squared. And they're both losing it, so I got to multiply it by 2. So there's 12 centimeters squared that I have to subtract. So I add 32 plus 48 and I get 80, and I subtract what they share. And they share 12 centimeters squared, so the total is 68 centimeters squared. Better examples coming in class, just be familiar with the actual concept. All right, dimension change. So we've done dimension change in 2 dimensions. So what happens when I do a dimension change in 3 dimensions? So here they give me this figure. I got 8 by 2 by 3. And if I do the original surface area, they get 92 millimeters squared. Then they do a dimension change and they multiply all the dimensions by 3. And they get a new surface area of 828. And notice what the change is. When I multiplied each side by 3, the change was that change squared. So if I square the 3, I get 9. If I multiply the original area by 9, I get 828. And they just have us do another problem, basically doing that same thing. So I'll start here. My original base area with my initial shape, 5 times 1 is 5. My initial lateral area, again, perimeter of the base times the height, will give you 24 centimeters squared. And so now the total, I have 2 bases, so 5 times 2 is 10. 10 plus 24 gives me 34 centimeters squared. But they then told me to multiply everything by 2. So it went from 5, now this piece is 10. This piece was 1, it's gone to 2. This piece was 2, it's now 4. So now what's the area? Well, my new base area, again, doing the same thing. I have 10 times 2, area is rectangle, but length times width gives me 20. Lateral area is now 96, and I do have 2 bases, so 40 plus 96 gives me 136. So that is my new surface area. So what is my change? If the dimensions are multiplied by 2, then the surface area is multiplied by 2 squared, or 4. 34 times 4 gives me 136. So my change, when I change all the dimensions on the surface area, is that change that I made was times 2 squared. Alright, so one last thing to talk about, and that is going to be nets. We haven't talked about nets in class yet. Quick picture if we've forgotten that you've seen it before. So if I've got a prism, this is a hexagonal prism, it's 3-dimensional. All a net is what does it look like laid down flat. So there's my prism. I don't know how well you can say, again, better examples in class, but that's all a net is. It's taking a 3-dimensional shape and laying it down flat. And so they've asked us to do that here. So it says use the grid to construct a net for a rectangular prism with edges having lengths of 2, 6, and 4. So if I do that, this is what my net would look like. There it is. So if I fold this up, it would make a rectangle that has lengths of 2, 6, and 4. We'll practice some of these in class. And just find the total surface area of the prism. All I gotta do is add up each one of these little boxes. So there's 8 boxes there, 12, 8, 24, and so on. And so my answer to this one would be 88 units squared. If you need to pause it to get that in. Last definition, again, just write this at the bottom. A net is a diagram of a three-dimensional figure that can be folded to create that three-dimensional figure. That's all a net is. We'll do some practice in class. Have these notes done, short quiz in class.